question number 6, a projectile is fired with a speed 20 meter per second at an angle 45 degree above horizontal. The coefficient of restitution of collision between the projectile and ground is 1 by 3. How far from the starting point does the projectile lands finally? We know that the range of the projectile on the ground is given as r is equal to u square sine 2 theta divided by g. So first of all, I have to calculate what is the value of r. The value of u is 20, so it is 400. Angle is 45 degree, so 2 theta is 90 degree. So sine 90 degree is 1 divided by value of g is 10. So it comes out to be 40 meter. Now we know that when the projectile goes in the repeated cycle, then the total distance covered by the projectile can be written as r plus er plus e square r and so on, where e is the coefficient of restitution. So if I solve this, it comes out to be r into 1 divided by 1 minus e. So if I substitute the value of r is 40 and the value of e is 1 by 3. So on further solving, it comes out to be 60 meter. So option 2 is the correct answer. Let's move to question number 7. In question number 7, a disk of mass m is given some angular velocity about a horizontal axis through its center and gently placed on a plank of mass 3m. The coefficient of friction between the two is 1 by 3. The plank rests on a smooth horizontal surface. The initial acceleration of the disk relative to the plank will be. So if I draw the free body diagram, so at this moment when the angular velocity is in this direction, the friction force due to the relative motion will act in this direction and it will be mu into mg. And on the plank of mass 3m, this friction force will act in this direction, mu m into g. So the acceleration of this disk in this direction is mu g and the acceleration of the plank in this direction is mu g by 3. Now I have to find out the initial acceleration of the disk relative to the plank. So relative acceleration would be mu g into 1 plus 1 by 3. So if I substitute the data, the value of mu is 1 by 3, the value of g is 10 and this is 4 by 3. So it comes out to be 40 by 9 meter per second square. So option 4 is the correct answer. Let's move to question number 8. In question number 8, a uniform rod of mass m and length L rests on a smooth horizontal surface. One of the ends of the rod is stuck in a horizontal direction at right angle to the rod. As a result, center of rod obtains velocity v0. The stress developed in the rod at midpoint of the rod will be, and A is the area of cross section. Let's analyze the situation. Suppose this is a uniform rod of mass m and length L. An impulse J is provided to this end as given in the question. Then I can write, if v0 is the velocity acquired by the center of mass immediately after the impulse, then I can write J is equal to m into v0. And if I write the equation of angular momentum about the center of mass, then J into L by 2 is equal to m into L square by 12 into omega. So if I substitute the value of J is equal to mv0, then on solving, the value of omega comes out to be 6v0 by L. So immediately after collision, if I find out what is the tension at the midpoint, then the tension at the midpoint can be written as the center of mass of this half portion will be at this position and it is at a distance of L by 4. The mass is m by 2. So the tension can be written as T is equal to m into omega square r. So m is m by 2, omega is 6v0 by L whole square and the value of r is L by 4. So if I calculate what is the stress developed, then the stress developed would be T by A. So if I solve this, it comes out to be 9 by 2 m v0 square divided by A into L. So option 2 is the correct answer. Let's move to question number 9. In question number 9, a system consists of a thin ring of radius r and a very long uniform wire oriented along axis of the ring. If mass of ring be m and mass of wire be lambda per unit length, then calculate angular velocity to be given to the ring so that tension in the ring is 0. So in order to have the tension in the ring to be 0, so the required centripetal force must be provided by the gravitational force. Let I am considering a small section and the mass of this section is dm, and let the angular velocity provided to the ring is omega. So the required centripetal force is dm into omega square into r, and this must be provided by the gravitational force. So that is equal to dm into gravitational field at the location of the element. So that is given by 2g lambda by r due to infinite wire. So on solving, the value of omega comes out to be 2g lambda by r square under root. So option 1 is the correct answer. Let's move to question number 10. In question number 10, figure shows a L-shaped tube placed in vertical plane in which a liquid of density rho is filled. What should be the minimum acceleration of tube? So in order that the no liquid will fall out of the tube, the surface of the liquid in the tube is something like this, and if this angle is theta, since this is 1 meter, this is 1 meter, so tan theta is 1 by 1, so the value of theta comes out to be 45 degree. Now if I draw the free body diagram, the G is acting in this direction, and we know that if this is the surface of the liquid, then the G effective would be perpendicular to this surface. So the G effective would act in this direction. Now if this is the direction of G, then I have to drop a perpendicular on this. So if the direction of acceleration of this L-shaped tube in this direction, then with respect to this frame, then in the frame of the L-shaped tube, we have to apply pseudo correction. So the acceleration would come in this direction. This is the direction of G effective. So I have to find out what is the value of this acceleration. So if I consider this as my G, then this angle is 45 degree. So the component of G in this direction is G cos 45 degree. So the value of A is equal to G cos 45 degree, or it is equal to G by root 2. So option 3 is the correct answer. Let's move to question number 11.